Sorry that we couldn't be there to present in person. Both Laura and I had finals during this time. So this semester, Laura and I have been working with Hafa and more recently with Alyssa on a project on adaptive performative autonomy. So in previous semesters, we conducted experiments on how a robot intentionally lowering its autonomy might impact perceptions of trust in the robot, the awareness of what the person's awareness of what the robot's doing, their cognitive load, and some other factors. And so the robot intentionally lowering its autonomy is what we call performative autonomy, meaning that even in situations where the robot could make the decision by itself, it instead asks the person it's collaborating with to either make decisions for it or confirm a decision that it's made. And this strategy aims to increase the awareness the person has of what the robot's doing, ideally without imposing like a large cognitive load. And so in that previous study, we just looked at the use of performative autonomy where the robot always used one of the three levels of performative autonomy, but didn't change between those levels. And so in this new study that we've been working on, we are instead looking at the impact of adapting the robot's level of performative autonomy during the course of an interaction. So our project has two main parts to it, with two experiments that we will need to run. So first, we want to gather more data to understand how these different levels of performative autonomy impact situation awareness and cognitive load. And we're manipulating performative autonomy based on how the robot communicates. So whether it's asking questions or for confirmation or just stating what it's doing. Then we're planning to use that data to train some adaptive model that changes the communication type of the robot based on the person's current awareness and workload in order to try to maximize their situation awareness and minimize their cognitive load. And we've been looking into different types of adaptive models for doing this, mostly reinforcement learning based, that we plan to sort of compare against each other once we have this experiment data. And so through this second experiment, we would be able to sort of evaluate our second research question, which is whether an adaptive model of performative autonomy compared to just a static model improves human-robot collaboration based on things like trust, perceived intelligence, or task performance, things like that. So I'll now turn it over to Lara to talk more about our methods, the experiments we plan to run, and what we specifically worked on this semester.
So this semester we have been working on getting the resource collection game, the situational awareness, and the cognitive load questions with the NBAC number game to work with the platform that we have now been using since we switched to an online experiment, and also making sure that we are collecting the data that we need to accurately train the models. The game is quite simple. It involves a robot collecting resources of 4 different colors for the player in a remote location, and the player has to move around a board and spend these resources, all while keeping track of the approximate amount of each color they currently have. And there are also situational awareness questions that pop up every interval of time. And lastly, there is an NBAC test where the player has to type in the last number shown when the question pops up. With both of the rounds of running the game, the first step and then the second step, first being data collecting and then that second being with the adaptive model, we will be collecting participant feedback on how well they think they successfully completed the task, how good of a teammate they think the robot was, and input on how to better their interactions for future reference. The last thing that they complete after this is the NASA TLX. We will be using this feedback to train the models, likely 3 options, to compare the model's performances, and then update them, most likely, every 3 participants for each model. So every time that 3 people run for each of the 3 models, we would then batch update that model, and then run it again. The final goal is to compare the human performance and the human opinion of the robot and the task between the static and the adaptive model. As of now, we have run pilot tests to make sure instructions were clearer now that we have implemented an interactive instruction panel instead of videos or simply in writing as it was before. And we have also been changing many timing issues to make the game less overwhelming so that we get valuable data on cognitive load instead of it all just being high every time. We have yet to see the results since we still need to run the experiment, but we expect to see a significant improvement with the adaptive models. This research will greatly benefit the HRI community by allowing for a more personalized experience in the field, by inflicting higher trust of humans on robots as teammates, and also by enabling accessibility and inclusivity in working with robots, since we could then adapt them to work with with what the human needs to thrive in that environment. Overall, we are on track and excited to finally wrap up this project next semester since it has been running for a little bit. And apologies again that we couldn't be there, but we wish everyone a great holiday break and good rest.